Welcome back. Today we'll be talking about exponential growth. So we'll be solving problems, and here is the equation. So exponential growth is a model. Usually population grows in exponential growth, and so the problems that we'll be dealing with will be population problems. And so here the formula looks very similar to the exponential compounding interest continuously. In fact, it's the same exact model, except the variables have different meanings. So for example, here P stands for the population after t years. So remember, this is a model, so it's predicting the population after so many years. P naught is exactly what the population started with when t was 0. When t is equal to 0. And that's something we forget to mention, but initial population means this is when t is 0, when we start. R will be the growth rate. Most of the problems that we deal with are going to ask us to find this. This is what we try to determine. And then the t is time. And the time sort of depends. Sometimes it'll be months, sometimes it'll be years. It kind of depends on what the question's asking, so we'll have to be careful with that. All right, so let's go ahead with the problem here. Okay, so here's the first example. So after the wolf population was decimated due to overhunting, the rabbit population in the Bolutu Game Reserve began to double every 9 months. Ooh, that's a lot. So what we're asked to find is, we want to find the growth rate R. And then we want to find the number of months required for the population to reach 5,000 if there were an estimated 200 rabbits annually at the beginning, initially. I think this word was supposed to be initially. Okay, so this problem splits up two things. First, it asks you to find the growth rate R, and then it asks you to do something with the information. So here's what we're trying to get you to understand when you see these problems. First of all, we want you to think of the formula. So we want to predict the population, and so we need an initial population, and we need E. We're going to multiply that times E, and then the growth rate, and then T. And notice that it says find the growth rate. That's the first thing it asks you for. But it doesn't tell you the initial population, and they don't tell you the population after so many years. And so the idea here is that when we say that the population doubles every 9 months, that should be enough. And here's what we mean by this. We don't know the population, but we know that in 9 months. So here's what I would think. This is my thinking cap. So think. If I start with P naught, that's how you say that, by the way, P naught. After 9 months, we have 2 times P naught. And so that's actually, you'll see right now that this is enough information for us to solve the problem. So, and right here, in this case, T would be 9. So we start with P naught, and after T equals 9, we end up with 2 P naught. Well, how does that help us solve this problem? Well, what I'm going to do now is say, well, let me shrink this up so we can have it later. Well, P I don't know, but I know after 9 months. So here's what the model says. So I have P naught, I have E times R to the R times 9. And after 9 months, I should have twice as much as what I started with. Well, remember that when we solve these types of equations, we always try to isolate the exponential, which is this part. So what we can do is we can divide by P naught on both sides. But that's okay, because P naught divided by P naught is 1, so they cancel. And P naught divided by P naught is also 1. And so I'm left with 2 equals E, and I like 9R. It looks a little bit nicer. But I know how to answer these. I actually know how to solve these questions. These are actually not too difficult. Here, if you recall, we take the natural log of both sides. So we take this function, which is called the natural log, and our input on the left will be 2, and on the right will be e to the 9r. And then we know more stuff. We know that, well, the natural log of 2 doesn't matter, but it's not going to change. Not that it doesn't matter, but it doesn't change. But here, the natural log and the e sort of cancel each other out. I'm left with r. I solve for r, so that means it's natural log of 2 over 9. Usually I leave my answer like this, but if you are going to round off, the growth rate is 0.0770163534. But if we're going to round off, I would say that the growth rate is about 7.70%. Okay, so we've done part A. That wasn't too bad. So we found the growth rate. The key here, what I wanted you to understand was that you don't need to know, as soon as they say double, you have enough information to find the growth rate. Okay, and this is the strategy. So whenever you see the word double in any of your problems, this is how you would approach how to find the growth rate. All right, but now the nice thing is that we do know the growth rate. So now we have a nice model. We know that P, and I should call it P of T, it's a function, depends on the population, the initial population. We have E, and we know what R is. We know R is 0.077 T. That's our model. That's what we can use. And now we can use this to solve V. And so here they tell us, they want to know when the population will reach 5,000 if initially we have 200. So they're asking us when, so that's P, or sorry, they're asking us for when, so that's T. They want to know what T is. But they're telling us that they want to know at 5,000, if P naught was 200, can you tell me what T is? And notice that this is almost exactly the same problem we just did. We approach it in the same way. We divide by 200 on both sides. This, if you want, you can put in your calculator, which is 25. And then this, again, we know that the easiest way to do these is to take the natural log. And the nice thing about the natural log with the E is that it cancels it. And so I'm left with natural log of 25 is equal to 0.0717. Now, I don't usually round, by the way. Just a little aside, I usually keep this number and wait till the end. Or I store it in my calculator, if you know what that means. But after you solve this, so I would go ahead and divide both sides by 0.077. And after you do this, but instead of 0.007, I'm really using that number, I get that T is approximately 42 months. And so that's how long it would take, which is kind of crazy if you think about this problem. And it's not that far off from reality. If you started with 200 rabbits and there is no wolf population to keep track of them, it would take less than 4 years for the population to reach 5,000. So it is quite a bit. All right, another example. Actually, let's stop the video here, and the next video will have the next example.